All right, studio audience ready?
Already recorded.
Excited, ready to go? Okay. In 5, 4, 3. And welcome to Pre-Calculus 10-2 with our studio audience.
Yeah.
Okay, so this is section 10-2. Let's get down to business. All right, now here we have a picture, and we're going to try to figure out in which interval or intervals, could be more than one, is f decreasing. All right, so when you do one of these, you read these graphs just like a book from left to right. Okay? So you start over here and you read the cross, and you can tell that it's rising and falling. All right? Now, where is it decreasing? Okay, let's see. Same on a roller coaster, right? Your heart sinks right here. Okay? When I get to -5, am I decreasing at -5?
No.
You know what? I'm actually not. Okay? Physics.
So
If you take a ball and you throw it up in the air, it goes up, but there's one point in time where it's frozen, it has zero velocity, and then it comes back down, right? You cannot go from plus to minus instantaneously. I want you to remember that about physics and math, okay? You could take a basketball and throw it off this ceiling here at 1,000 miles per hour. Okay? It's going to ricochet, well, it's going to bust through the ceiling, actually, okay, off the wall. But as fast as it's going, it has to have one moment where it is zero before it comes back, right? Okay? So you can't instantaneously go from forwards to backwards. It's impossible. There's a 0 point. Okay? Is that
so we're just supposed to assume that if you put a point near the top of the curve, that that's the top of the curve?
Yes, yeah. Because, I mean, you can look at it and say, well, is that really there? It's supposed to be there. Okay? All right. So, right here, you are not increasing, nor are you decreasing. You're kind of in between the two worlds, right? As soon as you get past the -5, you are decreasing. So I am decreasing from, where does it start? -5, but including -5? Excluding -5. Okay? That is kind of like a neutral slope is what it is, right? Slope balance. Okay? All the way until you get to what? You get to 1. Including 1? Actually, in the basin, you're going to be excluding, right? You're not increasing nor are you decreasing at 1. It's kind of like bouncing something off the floor. Well, Mr. Wade, what if I throw it off the floor really hard? Well, it still has to go down, 0, up. Okay? Oh, heck, what? We're on film right now. Special guest, ladies and gentlemen, Bailey Bogan. Welcome to the show. Oh, yeah. All right, let's bring out our first guest today. Okay, yes, get on camera. All right, yes, Bailey?
Can I have a bonus quiz?
Bonus quiz right now. Oh, yeah, that's right. You're playing this. I'm sorry. Okay, it's up there. Go to the top right-hand corner. Look for the one that is specially made for 6th period because they're all different. It should say made for 6th period.
Take them all.
All right. Now, if I have some more stuff to tell you about, I have to use a what? U for union. All right. Now, where else is this function decreasing right here?
8 to infinity.
From 8 to infinity. Now remember, when you write an interval, are you writing x coordinates or y coordinates? Intervals are x coordinates. Now the graph, the y coordinates are going down to -infinity, but we don't care about that. The x coordinates are going to infinity, right? So think about the y, think about the x. So from 8 to infinity, it will be decreasing. Should I include 8?
No.
Nope. You pretty much never include in this problem because that's the barrier between going up and going down, but it's neither one. And can you put a bracket on infinity? Never. You can't ever touch infinity. Try. Count to infinity. Start. Okay? Yeah. All right. Come back when you're 75. Tell me how far you got. All right? Okay. It's impossible. Okay. There's your answer right there. Now, where is this picture up here decreasing? Or no, sorry, we'll do that. Increasing. Can you tell me where it begins to increase? From the beginning of time, right? Okay? From the beginning, this graph was increasing.
In the beginning.
Yes, in the beginning. I can't say that. Okay, now, so from...
With the dinosaurs?
You'll be in the land before time if you don't start paying attention. Okay? This is a joke. Parents are watching. Okay? We kid around
Have mom
sometimes.
watch this.
Oh, okay, yeah, Sue was kidding around. All right, now, okay, so it is going to be increasing until we get to, yep, and infinitely close to -5, just before it, right? So excluding
I thought you said pi.
union, where else is this roller coaster increasing?
8.
From 1 to 8, something including? Excluding, that's right. Okay? So we're dodging around these neutral places here, aren't we? All right? Where you're not going up, you're not going down. You're changing direction. Okay, now, let's mention those places. See, where does F have a neutral slope? So where do we have a neutral slope?
-5.
At this peak,
This one.
this valley, and this peak. Those are the places where the direction changed, right? And what do we say? You can't go from up to down unless there's a neutral in between, okay? You can take a car, put a dummy in it, and run it into a tree at 70,000 miles per hour. It doesn't matter. You can't go from forwards to backwards, okay? You know, that's not nice, all right? It doesn't matter, all right? You take a rocket and crash it off something. It doesn't matter how fast you're going, you can't go from plus to minus, okay? Actually, that kind of relates to the challenge a little bit. If something is going down, it's negative, right? Okay? And if it's going up, it's positive, right? That's, well, if you get a certain answer and it's negative, you're like, how can you have negative velocity? Oh, because something's going down, okay? So, but you can't go up and down, you have to go up, neutral, down, okay? So remember that. All right, there you go. Now, oh, by the way, these are places where the slope is what again?
0.
So you mean when you get to a peak or a valley, the slope kind of levels off, right? Okay? It does, doesn't it? That would mean that these numbers right here are called what? They are. They're also something else that we talked about yesterday.
X-intercepts. Zeros.
Roots.
Roots.
They are roots of the derivative. Critical number. That was a pre-plan plus 10. Plus 10 and a half. Oops, step behind.
You mean stepping?
Step behind. Very nice, very nice. Got the pre-plan plus 10. What are critical numbers again? When the derivative equals 0. What does slope, how do you measure slope? The slope is the what? Slope is the derivative. When the slope is 0, the derivative is 0, and those are called critical numbers. How about that? And that's why they're so important.
Right, so where they're the neutral points are critical points?
So when the slope is neutral, okay, when the slope is neutral, that's called a critical number, because the slope is the derivative. All right? So the critical numbers are the direction changes. When did I go from up to down or down to up? Okay? Or like going way ahead, when you get to calculus, late in calculus, we'll have this problem where you're running a business and I want to maximize my profits. And you have this curve of all your profits. Do I want to be down here?
Yes.
That's bankruptcy. That's minimum profit. That's maximum profit. You want to get to the peak. And you want to find that direction change. Okay? Or investing in the stock market, pulling your money out at the right time. Try to get to the peak. Okay? Lots of real life examples on this one, which we'll do in calculus. Okay? And a couple in here too. All right, so I'll tell you what, before we go on, let me make this connection here. This is the link. Do you notice, let's take a random point right here. Just draw a little point. And I want you to draw a what?
Tangent line.
Tangent line. If the graph is increasing, do you notice anything about the tangent line? Positive slope. I bet there's a direct correlation there. I bet the steeper the increase, the steeper the slope. I bet the more shallow the increase, the more shallow the slope. We've talked about that before. Pick a point over here somewhere between 8 and 10, let's say, or anywhere.
9.
Anywhere past the 8. If you draw the tangent line, if the graph is decreasing, its tangent slope must be what? Negative. Direct correlation right there. And most important, if you arrive at a peak or a valley where you're not going up, you're not going down, you're in equilibrium here, the slope is 0. Okay? Here we go. And how do you find the slopes of the tangent lines? Going to the what? Slope of the tangent line. Always find the slope of the tangent line by going to the derivative. Okay? So we're going to go to the derivative. We're going to test it out on a number line like we did yesterday with the original function. and figure out where's the graph going up or down. If you don't even know what the graph looks like, you can test it out. Okay? All right, so here we go. Let's try D. We have no idea what that graph looks like.
Product rule.
All right? So let's examine the derivative. What it says is, where do you have neutral slope? Where are you not going up, not going down, you're just neutral? Okay? All right, well, let's find out. Okay, neutral slope. And when you see the word slope in this class, hopefully you think of taking the derivative. But neutral slope, okay? I'm at a peak on the roller coaster, or I'm at a valley on the roller coaster. That would be where the derivative equals 0. So you're trying to find the critical numbers. All right, let's try it. Now, we don't know what this graph looks like, but we're going to find out enough information where you can actually sketch it and figure out exactly what it looks like. Okay? So, let's take the derivative. Who remembers the rule that will take this derivative?
Product rule.
Isn't that a product rule? But Mr. Wade, I thought I could just take the 3 down and bring it to the front.
No, you have an X in there.
Well,
Good try. Well,
yeah. I'm afraid you cannot do that. If the front coefficient has a variable, you cannot bring the 3 down. Always use the product rule if both groups being multiplied have a plus. Variable, sure. It's a variable times a variable. You have to use the product rule. No way around it. Okay, so ho d high equals high d ho. All right, so the second one stays the same. That's ho times d high. What's d high? That's 3. Plus high stays the same times d ho. How would you take the derivative of that box right there?
Down.
3 to the front.
Base is the same.
Base stays the same.
Drop power by 1.
Okay, down to the second power. Ah, yes, the most important part. Times 2. Which the very first time we did the product rule test, some of you forgot that extra times 2, but by now you can probably all do it right. You've done it so many times. It's all instinct, okay, which is good. Okay, when you get used to something you notice, it's all instinct. You just do it, not think about it. Okay?